You are not going to believe what deep space telescopes just picked up. A massive interstellar object is heading straight for Mars, and the impact could happen within weeks. This isn't science fiction. This is happening right now, and NASA is scrambling to figure out what comes next. But here's what they're not telling you about what this means for us on Earth. My name doesn't matter. What matters is that I've been following this story since the first detection signals came through 3 days ago. And what I've uncovered is going to change everything you thought you knew about our solar system's defenses. It all started on a Tuesday morning. Dr. Sarah Chun at the Mauna Kea Observatory in Hawaii noticed something very odd in her data. She was tracking routine asteroids, the kind of work astronomers do every single day. But this time was different. The object wasn't following any normal orbital pattern. It was moving too fast. Way too fast. And its trajectory was all wrong. She ran the numbers 3 times because she couldn't believe what she was seeing. This thing was coming from outside our solar system, making it only the 3rd confirmed interstellar object ever detected. The first was Oumuamua back in 2017. The second was Borisov in 2019. Both of those just passed through our solar system and left. But this new object, designated 3I Atlas, isn't just passing through. It's on a collision course. Dr. Chun immediately contacted her colleagues at NASA's Jet Propulsion Laboratory. Within hours, every major telescope on Earth and in orbit was pointed at this object, desperate to gather as much data as possible. What they found was terrifying. 3I Atlas is huge. We're talking about an object roughly 12 kilometers across. That's 7.5 miles of rock, ice, and who knows what else hurtling through space at over 105,000 miles per hour. When the initial reports hit the scientific community, there was immediate, but contained, panic. The kind that happens in classified briefings, not on the evening news. Because here's the thing, nobody wanted to say out loud at first. They weren't sure if Mars was the only target. The early trajectory models showed a 38% chance that 3IA Atlas could use Mars gravity to slingshot directly toward Earth. 30–80% might not sound like much, but when you're talking about a potential extinction-level event, those are terrifying odds. Let's back up and talk about what we actually know about this thing, because the details are absolutely wild. Interstellar objects are ridiculously rare. Think about it. Space is so unbelievably vast that the chances of something from another star system entering ours is like throwing a grain of sand from New York and having it land in a specific coffee cup in Tokyo. When Oumuamua was discovered, scientists argued for months about what it was. Some even suggested it might be an alien probe. Borisov was more normal. It looked and acted like a comet. But 3I Atlas is neither normal nor boring. First, its composition is confusing everyone. Spectroscopy data, which tells us what an object is made of, shows a signature that doesn't match anything in our database. It has traces of organic molecules, but also heavy metals and a weird crystalline structure that one researcher told me looks almost artificial. Not alien artificial, but too structured to be a natural rock. The shape is another mystery. Unlike a typical roundish asteroid, 3I Atlas appears to have an irregular, angular structure, maybe even with flat surfaces. And then there's the rotation. Most space rocks tumble and spin. 3I Atlas is barely rotating at all. It's moving like an arrow pointed directly at Mars. This stability is extremely unusual for an object that has been traveling through interstellar space for potentially millions of years. And the final weird thing? It's not out. Comets are dirty snowballs that release gas and dust as they heat up, creating a tail. This object is getting hotter as it approaches the sun, but there's no tail. It's just absorbing the radiation. So, where did this thing come from? Astronomers have traced its path back to a region of space near the constellation Lynx. About 63 light-years away, there's a star system there. And about 8 million years ago, a supernova exploded nearby. The shockwave could have ripped apart a planet in that system, flinging fragments into interstellar space. Some scientists think 3I Atlas is a fragment of a destroyed planet. If that's true, it could contain minerals, organic compounds, maybe even fossils from an alien world. The problem is, we won't get to study it if it slams into Mars. So, what happens when a 12-kilometer rock hits Mars at 105,000 miles per hour? The energy release would be about 4.2 million megatons of To give you context, the asteroid that wiped out the dinosaurs was about 4% more powerful, but it hit a much larger planet with a thick atmosphere. Mars would not survive this intact. The impact would create a crater roughly 150 kilometers across and 20 kilometers deep. The entire planet would ring like a bell, with massive Marsquakes shaking the globe. But the crater is just the beginning. The ejectita rock and dust thrown out by the impact would be launched into space with such force that a huge chunk of Mars's thin atmosphere would be stripped away. Rock and dust would be ejected at escape velocity, and some of it would form a temporary ring around the planet, and some of it would be flung toward Earth. Now, before you start building a bunker, most of that debris would burn up in our atmosphere. But we're talking about millions of tons of material scattered across the inner solar system. We would see meteor showers like nothing in recorded history. Potentially for years, the dust cloud from the impact would spread out, possibly affecting solar radiation and slightly cooling Earth, while also creating spectacular sunsets. But Mars itself would be fundamentally changed. The impact would sterilize the surface even more, and any liquid water that might exist underground could be boiled away. And think about this. We have equipment on Mars: the Perseverance rover, the Ingenuity helicopter, orbiters circling the planet. All of it represents billions of dollars and decades of scientific work. Depending on where 3I Atlas hits, it could all be destroyed. But there's something else, something bigger. Mars is humanity's backup plan. It's the only other planet in our solar system we could potentially terraform and colonize. If 3I Atlas devastates Mars, it sets back those plans by decades, maybe centuries. We do have to wait for the planet to stabilize before we could even think about sending humans there. When the full implications became clear, NASA activated emergency protocols. The Planetary Defense Coordination Office, which usually tracks objects threatening Earth, suddenly had to expand its mission, defending another planet. What can they do? The options are limited and sound like they're straight out of a movie. They could try to hit it with a kinetic impactor, like the DART mission, to nudge it off course. The 3I Atlas is huge and moving incredibly fast. A small nudge might not be enough. Another option is a nuclear device. Detonating a nuke near the object could vaporize part of its surface, creating a rocket-like thrust to push it away. But the politics of launching a nuclear weapon into space are complicated, to say the least. Right now, the world's space agencies are in a frantic, desperate race against time. Every hour, 3I Atlas gets closer. The fate of Mars, and a big part of humanity's future in space, hangs in the balance. The next few weeks will determine whether our neighbor planet suffers a catastrophic blow, and what that means for the future of our own. Thanks for watching. This story is developing fast, so make sure you subscribe and hit that notification bell. We'll keep you updated as soon as new information comes in. Stay safe. We can't defend Mars. It's a harsh reality, but we simply don't have the technology, the time, or the resources to stop what's coming. This isn't like the DART mission, where we gently nudged a small asteroid. The object named 3I Atlas is a monster from interstellar space, moving at unimaginable speeds. All we can do is watch, record, and prepare for the consequences. Every major telescope on and off this planet is now pointed at Mars. Even the James Webb Space Telescope, which usually peers into the dawn of time, has turned its powerful eye toward 3I Atlas. The data we're collecting is incredible. We're relearning more about these interstellar visitors in a few weeks than we have in all of history. But this knowledge comes with a terrible price. We are watching a planetary catastrophe unfold in slow motion. NASA is even scrambling to launch a new mission, nicknamed Rio, the Rapid Impact Observer. The plan is to send a small spacecraft hurtling towards Mars, arriving just in time to get a front row seat to the collision. It would be packed with cameras and sensors to capture every single detail. This data could be priceless for planetary defense, but it's controversial. Should we be spending money to watch a disaster when we have so many problems right here on Earth? It's a tough question, but this event has united the world in a way we've never seen. The United Nations has convened emergency sessions, Every spacefaring nation, the US, China, Russia, Europe. India is sharing data in real. Even private companies like SpaceX have offered their help. It's a beautiful display of cooperation. But beneath it all, there's a current of deep, unspoken fear. Because everyone is asking the same terrifying question. What if we're wrong about the trajectory? Right now, the models show an 87% chance that 3I Atlas will hit Mars. That's incredibly high, but it's not 100%. There's a 13% chance it misses. And if it misses, its path brings it closer to Earth. Now, let me be very clear. Even if it misses Mars, the chance of it hitting us is tiny, less than 2%. But when you're talking about an object that could cause an extinctional level event, 2% is 2% too much. The problem is uncertainty. At this distance, the smallest, undetectable change in its path, a tiny puff of gas, a nudge from solar radiation, could be the difference between a Mars impact and a Mars flyby. If it flies by, Mars's gravity will act like a slingshot, flinging the object onto a new path. It could be sent careening toward Earth, or Venus, or even into the Sun. We just won't know for sure until it's too late to do anything about it. This uncertainty is why the Planetary Defense Coordination Office has quietly raised Earth-est Threat Level 2 Code Orange. That's the second highest level, and it's not public knowledge yet, to avoid mass panic over what is still a small probability. But behind closed doors, scientists and governments are running the scenarios. What do we do if it's heading for us? The questions are impossible, and the answers are non-existent. We've never faced a threat like this. For the scientists on the front lines, the psychological toll is immense. They've spent their lives looking at the stars with wonder, and now they're watching one of those stars come to kill a planet. Some are buried in their work, analyzing data 24/7. Others are struggling to cope, faced with a reality that feels ripped from a disaster movie. As I'm recording this, 3I Atlas is less than 2 weeks away from Mars. In a few days, it will become bright enough to be seen with a good pair of binoculars, maybe even the naked eye from a dark location, and that's when this stops being a scientific curiosity and becomes real for everyone. Once people can look up and see the threat with their own eyes, the global reaction will be intense. We're wired to respond to visible dangers, and it doesn't get more visible than a cosmic cannonball you can watch approaching day by day. NASA is preparing to manage the public message, but social media is already a firestorm of conspiracy and fear. Soon, it will dominate every news cycle, every conversation. The night sky itself will feel different. That faint, new point of light will be a constant, silent reminder of the awesome and terrifying power of the cosmos. Everyone will be looking up, thinking the same thing. An object from another star is about to hit our neighbor. The final days will be a whirlwind of scientific activity. The Perseverance rover on Mars has been moved to face the impact zone. If it's Orbevis, it could send back the first ever ground-level view of a major impact event. The orbiters have been moved to a safe distance, ready to record the aftermath. And then, the final moments. As the object enters Mars's gravity well, we will finally know for sure. The last bits of tracking data will confirm either an impact or a flyby. In those last hours, the entire world will be holding its breath. If it hits, the impact will be instantaneous, in a fraction of a second. All that incredible energy will be released, and Mars will be changed forever. We won't see the flash from Earth, but within hours, the effects will become visible. A colossal dust cloud, larger than any storm we've ever seen, will erupt from the surface. Within a day, telescopes on Earth will see it. Within a week, the red planet might not look so red anymore. The impact will dredge up materials from deep below the surface, potentially changing its color and scarring its face with streaks of debris. For all of human history, Mars has been a symbol of our dreams and our future. To watch it be so violently wounded feels personal. The scientific data will be a treasure trove, keeping researchers busy for decades. We'll get close-up images of the crater, watch the atmosphere being ripped away, and analyze the composition of an object from another solar system. It's a scientist's dream, born from a planet's nightmare. But beyond all the science, this is a profound, emotional event. It's a brutal reminder that the universe is not a gentle place. It's a wake-up call, showing us just how fragile our existence is in the grand, cosmic scheme of things. Whatever happens next, our view of the universe and our place within it will never be the same. Thanks for watching. This is a developing situation, and we'll be here to bring you the latest updates. If you found this informative, please consider liking this video and subscribing for more. Stay safe and keep looking up. For weeks, even months after the impact, we're going to see the fallout here on Earth. About 3 months later, the first pieces of Mars will start reaching our orbit, creating spectacular, yet somber, meteor showers. Every fiery streak you see will be a violent reminder of what happened to a piece of Mars burning up in our own atmosphere. The dust will arrive more slowly, taking 6 months to a year to really build up. We'll notice it first in our sunsets, which will blaze with new alien colors as the Martian particles scatter the sunlight. Scientists are already setting up collection stations to gather this dust. Martian meteorites are incredibly rare, but soon we'll have an unprecedented amount of new material to study. It's a silver lining, but a very thin one. Here's what's truly keeping me up at night about this whole thing. 3I. Atlas is the third interstellar object we've ever detected, and it's the first one we've seen directly threatening a planet in our solar system. This suggests that these cosmic collisions might be far more common than we ever imagined. Our solar system is 4.5 billion years old. In that time, Earth's been hit by countless asteroids and comets. Think about the impact that wiped out the dinosaurs, or the one that might have formed our moon. We've been struck by dozens of devastating objects throughout our history, but all of those were from our own solar system. They were like rogue family members. 3I Atlas is different. It's an outsider, a cosmic bullet fired from another star system millions of years ago, hurtling through the void until it happened to cross our path at the worst possible moment. The statistics are sobering. Astronomers estimate there could be trillions of these rogue objects drifting through interstellar space. Think about it. Entire planets ejected from their home systems, asteroids flung out by gravitational chaos, fragments of shattered worlds. Most of them will drift forever in the dark, but some, inevitably, will find a target. And when they do, they'll be moving at unimaginable speeds, carrying more destructive energy than anything from within the target system. Earth has been lucky. 4.5 billion years without a confirmed interstellar impact. But 3I Atlas is proof that our luck can run out. If this object had been aimed at Earth instead of Mars, we might have had only weeks to prepare for the end of civilization. And that's not an exaggeration. An object this big, moving this fast, hitting Earth would be catastrophic beyond comprehension. The dinosaur killer was bad enough. It was moving slower. An interstellar impactor would be orders of magnitude worse. This raises some deeply uncomfortable questions about planetary defense. We've gotten pretty good at tracking objects in our own neighborhood. We know where most of the dangerous asteroids are, and we're developing technology to deflect them. But you can't defend against something you can't see coming. Interstellar objects can approach from any direction at incredible speeds. We might get a few months' warning, maybe only a few weeks. Our current deflection tech is designed for slow-moving targets we can gently nudge over years. Against something like 3I Atlas, we are essentially defenseless. If it were coming for us, our only options would be bunkers and prayers. For a species that prides itself on technology and planning, that's a terrifying thought. There's something profound about watching this unfold in real time. We are witnessing the kind of event that has shaped planets across the universe for billions of years. Impacts like this have destroyed worlds, created moons, and delivered the very building blocks of life to barren rocks. From a purely scientific standpoint, this is an incredible opportunity. We're about to gather data that will rewrite our understanding of planetary formation, impact dynamics, and the hazards facing any civilization out there in the cosmos. Future scientists will study the 3I Atlas event for centuries, but from a human perspective, it's a gut punch. We're about to watch Mars die, or at least suffer a wound from which it will never fully recover, and we're being reminded, in the most visceral way possible, that we are not safe. The universe is vast, dangerous, and utterly indifferent to our existence. This is the dark side of cosmic awareness. When you truly grasp the scale of space and time, when you understand that events like this happen constantly, it's both awe-inspiring and terrifying. We are so small, our planet is so fragile, and the threats from the cosmos are so far beyond our control. But here's the thing. Knowing the danger is the first step toward dealing with it. Before we detected the first interstellar visitor, Oumuamua, we didn't even know these objects regularly pass through our system. Now we know they do. Before 3i Atlas, we didn't know they could pose a direct threat. Now we know they can. This knowledge, paid for by Mars's suffering, might just save Earth one day. It will push us to develop better detection systems, to work on faster deflection technologies, to take this threat more seriously. In a strange way, Mars is taking a bullet for us. By the time you watch this video, the impact might be just days or even hours away. The exact timing is still being refined, but the window is closing fast. Right now, 3i Atlas is hurling towards Mars, an unstoppable force meeting an immovable object. Telescopes across the globe and in space are locked onto it. Scientists are running their final calculations. The world is waiting. There's this strange mix of anticipation and dread in the air. We want to see what happens. We're curious about the science, the images, the insights we'll gain. But we also don't want it to happen. We want Mars to be spared. We hope for a last-minute miracle. But the laws of physics are absolute. The trajectory is locked in. In those final hours, as the object closes in, there will be a global moment of shared experience. People from every country and every culture will be watching the same event unfold. United in our concern for Mars and our fear for what it means for Earth, the impact will happen. The data will flow, and humanity will have survived its first close encounter with an interstellar threat changed. But still here, we will learn from this. We will adapt. We will prepare for the next time, because there will be a next time. It may not be in our lifetimes, but the universe is patient. Mars is about to show us just how real the threat is. This is the most important astronomical event of our generation. It's a tragedy, a scientific goldmine, and a wake-up call, all at once. Whatever we learn in the next few days, one thing is certain. We will never look at the night sky the same way again. And maybe that's the real impact, not the crater on Mars, but the crater it leaves in our cosmic complacency. The understanding that we are vulnerable, and we need to be ready. Thank you for watching. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the cosmos. And be sure to watch the next video to see what NASA might not be telling you about Earth's defense systems. Stay curious.